Welcome back to Table Talks. So we are still moving on to another part, that is now part B. We are looking at how to differentiate using first principle of part B, which is also, you can start by saying let y equals 1 over x squared. This is the first equation. You can say taking delta y, comma, delta x as small changes in y and x respectively. So what are we going to have? We have y plus delta y equals 1 out of x plus delta x, the whole of it squared. And I say this is the second. Then from this equation 2 minus 1. So what am I having? I'm going to remain with delta y equals 1 out of x plus delta x, the whole of it squared minus 1 out of x squared. So can we go ahead and we find here the LCM? So what is the LCM? The LCM remains as x squared into x plus delta x squared. So this one we are remaining with x squared minus x plus delta x, the whole of it squared, which becomes x squared minus expand x squared plus 2x delta x plus delta x, the whole of it squared, all over x squared into x plus delta x squared. So can we try to open? We are getting x squared minus x squared minus 2x delta x minus delta x squared all over x squared into x plus delta x squared. So what is happening with x squared? They are going. So I'm remaining with negative 2x delta x minus delta x squared all over x squared into x plus delta x, the whole of it squared. But delta x squared is equal to 0. But delta x, the whole of it squared equals 0. So can we try to substitute in and we see what we shall likely come out with. So we are remaining with delta y, which is equal to negative 2x delta x all over x squared into x plus delta x, that's 1 squared. Then we go on dividing by delta x. What are we having? We have delta y over delta x, which is equal to negative 2x all over x squared into x plus delta x, the whole of it squared. Then we say as delta x tends to 0, then delta y, delta x is approximately equal to dy dx. So what does it become? What does it become? What does it become? It becomes dy dx, which is equal to negative 2x out of x squared into delta x is already 0, we get x plus 0, the whole of it squared. So when you got it, it becomes negative 2x all over x squared times again x squared, which becomes negative 2 out of x cubed. So therefore d dx of 1 over x squared, so we are coming out with negative 2 over x cubed when we have already differentiated from the first principle. So we are going to part C. So also in part C, we also say let y equals 2x squared plus 3. So we still taking delta y, comma delta x as small changes in y and x respectively. So what are we having? We have y plus small change in y equals 2 into x plus small change in x, the whole of it squared, plus 3. Then we say this is the second equation. Then from there we say equation 2 minus 1. So what are we going to remain with? We're going to remain with delta y equals 2 into x plus delta x, the whole of it squared, plus 3 minus, the first one is 2x squared plus 3. So can we go ahead and we try to expand? So this is 2 into expand, we are getting x squared plus 2x delta x plus delta x squared. Then outside is a plus 3, then minus 2x squared minus 3. So can we try to open up the brackets? We have delta y equals, this is 2x squared plus 4x delta x plus 2 delta x squared plus 3 minus x squared minus 3. So what we're going to do, we are going to collect like terms and we try to reduce as far as possible. So we are having delta y which is equal to 2x squared goes, and we say that a delta squared is equal to 0. So we are remaining, you can first say, you can say this is 4x delta x plus 2 delta x squared, but a small change squared is equal to 0. So we are remaining with delta y equals 4x delta x. Then you can say dividing by delta x. So can we divide by delta x? You are getting delta y over delta x, which is equal to 4a delta. We are dividing, that means delta x has disappeared. Then you can say as delta x tends to 0, delta y delta x is approximately equal to dy dx. So what does it become? It becomes dy dx equals 4x. Therefore, ddx means when I differentiate 2x squared plus 3, I'm coming out with a 4x. And I've tried to solve that one. Equally, we are going to go to part D and we see the solution for part D when we are using the first principle. We're on part D. What is it saying? You see, I'll say let y equals 3x squared plus 5x. So we also say taking delta y, can say taking delta y comma delta x as small changes in y and x respectively. So one take those small changes, so I'm having y plus small change in y equals 3 into x plus small change in x squared plus 5 into x plus small change in x. So can we try to can say this is the second, or can we first expand? We get y plus small change in y equals 3 into x squared. From binomial theorem, we're getting x squared plus 2x delta x plus delta x squared, then plus 5x plus 5 delta x. So when we try to go ahead, we are getting 3x squared plus, this is a 6x delta x plus 3 delta x squared then plus 5x plus 5 delta x. Can we try to collect terms? We are getting 3x squared plus 6x delta x, then plus 5x. When we say they are not related, that one, plus 5 delta x squared delta x. This one is already 0, which is equal to y plus delta y. Can still even add plus 3 delta x squared. We say this is the second equation. Then we say this was 1. We say equation 2 minus 1. When we say equation 2 minus 1, what are we getting? We are remaining with delta y, which is equal to 3x squared plus 6x delta x plus 5x plus 5 delta x plus 3 delta x squared minus, the first one is 3x squared minus 5x. So 3x squared and 3x squared goes, 5x and 5x still goes. We remain with delta y equals 6x delta x. We know that delta x squared is 0, we remain with 5 delta x. Then we say dividing by delta x. So we are going to remain with delta y over delta x, which is equal to 6x plus 5. Then we also say as delta x tends to 0, comma, delta y, delta x equals dy dx. So we are having dy dx, which is equal to 6x plus 5. So we conclude and say, therefore, d dx of 3x squared plus 5x, we are coming out with 6x plus 5. So we have tried to differentiate that one using the first principle attempt. That's what we can do with such kind of the number.